Dear learners, welcome to the class of production function with two variable inputs. In our class today, we are going to talk about production function with two variable inputs. We are going to consider labor and capital as two variable inputs. Remember, the quantity produced here is going to be a function of capital K and labor L. This function can be represented graphically by using isoquant curves. What is an isoquant curve? An isoquant curve is a curve which shows various combinations of, for example, capital K and labor L, and that produces the same quantity of output. It is also observed that diminishing returns are observed when we substitute one factor with another. And this is the reason for the convex shape of the isoquant curve. Let us talk about the returns to scale. Increasing return to scale, when, for example, we double the input and the output is more than doubled, we say that the increasing return to scales are operational. When on doubling the inputs, the output is also doubled, we say that constant returns to scale are operational. And when on doubling the inputs, we get less than double the output, we say that the decreasing returns to scale are operational. Let us talk about production function through isoquant curve. Remember, in the long run, all the factors are variable. So in our case, capital and labor are both variable factors in the long run. So quantity produced, again, we say is a function of different inputs from capital and labor. An isoquant curve is a contour line which is drawn through the set of the points, and it represents the same quantity produced by using different combinations of capital K and labor L. Isoquant curves are used by the producers to solve the cost minimization problem by the producers. When we add one input and hold other inputs constant, then this leads to the diminishing returns of the output. And this is reflected in the shapes of isoquant curves. A typical isoquant curve looks like this, sloping downward. And let us see that quantity 1 is produced along the Q1 isoquant curve. And here we take into consideration various inputs of y and x. Various combinations of y and x produce same quantity along all the points of Q1 isoquant curve. Same is the case with Q2 curve and Q3 curve. Let us now talk about the properties or the characteristics of the isoquant curve. An isoquant curve typically slopes from left to right. This is because when we are using or when we are reducing the combination of capital K, let's say from K1 to K2, we have to increase the labor from L1 to L2, and this is depicted in the shape of the downward slope from left to right. Isoquant curves cannot cut each other. Here on your screen, you can see that Q1 and Q2 are two isoquant curves and they are intersecting each other at point H. This indicates that the same combination of K and L is producing at point H is producing two different quantities Q1 and Q2, and that's not possible. Isoquant are convex to the origin. They slope from left to right, and this is because of the no two variables are perfect substitutes of each other. So y may not be perfect substitute for x, may not be perfect substitute for y, and y may not be perfect substitute for x. Isoquant curves are also elliptical in shape, and the reason for the elliptical shape of isoquant curve is the law of diminishing returns. As we go on increasing one factor, it is ultimately the total product is going to decrease, and that's the reason for the elliptical shape of the isoquant curve. Now let us talk about economies of scale. Economies of scale, they can be related with the cost reduction activity of the firm. As the firm goes on increasing the production, the cost per unit comes down, and this is depicted by economies of scale. Return to scale is, on the other hand, it describes the input-output relationship. A production function has constant return to scale if, for example, on doubling the inputs, we get doubled output. So the production function is said to have constant return to scale. If on doubling the inputs, we get less than double the output, then we say the production function has decreasing return to scale, and the production function is said to have increasing returns to scale if, for example, by doubling the inputs, we get more than doubled outputs. Types of economies of scale. There are two types of economies of scale: internal economies of scale and external economies of scale. Internal economies of scale are those which are internal to a firm or which are internal to an organization. Here you can see the types of internal economies of scale. So you have technical economies of scale. Technical economies of scale result from the efficiencies in the production. When a firm or a company is technically sound, it produces technical economies of scale. A firm can have managerial economies of scale when they are in a position to hire or to recruit the best of the human resource, best of the managerial personnel for their firm. Financial economies of scale are said to operate when a firm has easy access and cheaper access to the finances. Network economies of scale occur when a firm has a strong network. This is also possible in case of the online businesses. Social economies occur because of goodwill of the firm, because of the popularity of the firm in the society. External economies of scale are external to a company, and the company does not has, or the firm does not has, a control on these external economies. For example, government may prefer certain firms and they may give tax benefit to these firms, and this can result into the external economies of scale for those preferred firms. This is done to attract the companies, since these companies provide jobs to the citizens of that particular place. Thank you.